All right, can y'all see? Yeah, it looks like y'all can see what I'm sharing. First, an introduction to AI for all. It is our mission to increase diversity and inclusion in AI development, education, policy, and research. One of the things that I think is important about this mission is that it is all of those things. It's not just AI development or just AI policy. We want to bring more voices to the table in all of those places. So why teach artificial intelligence? Because it's everywhere. And 85% of Americans use it regularly. It's going to basically regardless of what they do. But there's not a lot of diversity in who makes the AI. So we want to change that. We want to build a community of diverse leaders. And again, these are policymakers, these are artists, bioinformatics researchers who are aware of what AI is and how it can help them in what they do. AI for All has a bunch of different programs that do this, which includes college pathways for college students who maybe are not AI majors yet, but want to be exposed to it. Also, summer programs, which are usually in colleges and universities and are trying to, you spend a couple weeks there totally immersed in AI. And how it works and such. Or there's open learning, which is what I'm going to tell you most about. Open learning is meant for high school teachers of any subject to be able to teach AI to their students. It's largely on its impact, what it is, again, how it can be used in varying areas that might be important to you. And then we also have a Changemakers program for our alums of our other programs to have a supportive environment to keep learning more. So it is open learning's philosophy that anyone can teach AI, and more importantly than that, everyone has something to bring to teaching AI. So I always use the example of Remy in Ratatouille. In Ratatouille, there is that book, Anyone Can Cook, and the critic gets upset that the critic gets upset. No, not anyone can cook. It is an art. It is important. And then he realizes, this excellent food that I just ate was cooked by a rat. That's what anyone can cook means. It means don't have preconceived notions about what a good cook looks like. This is sort of my philosophy of AI teachers. If you are an English teacher, you understand a lot about how students make sense of words. You understand how students learn about why something is a positively phrased article versus a negatively phrased article, and how to teach them how to find those meanings in those words. You will be better at teaching students about how computers find those things, how computers decide sentiment of articles, because you understand this from English. If you are a music teacher, you were probably passionate about instruments and new ways of understanding and making music, and how they fit in the history of music. You will be a good AI teacher because we are using AI to make new kinds of instruments, and also because AI is learning from all these old music pieces, and you will be better able to explain that. So yes, anyone can teach AI, but it is because you are bringing so much to the table and not because teaching AI is super easy. We do make it as easy as possible. We have teacher guidelines, but it is not, I believe very strongly in empowering teachers over and helping teachers see what they are bringing to the table over just making it, oh, well, don't worry, it's so easy, anyone can do it, right? Not just anyone, you can do it. Open learning, like I said, for high school teachers, high school classrooms, students explore AI through lots of things, especially impact, and it has interdisciplinary applications. We align to Common Core standards, NGSS standards, ISTE, CSTA. There was an arts framework standard that I found that our dance curriculum aligns to. And that's because all of these subjects require critical thinking and discussion and research processes and thinking about ethics and collaboration. And also our curriculum doesn't necessarily require math or programming. So there's lots of different ways that you can explore AI as an artistic tool, understanding career paths, understanding policy, what policy should be made about AI and why, analyzing articles, analyzing sci-fi, right? Things that you're already doing in your classrooms, regardless of what your classrooms are. The overall learning goals, we want to make sure students know what is AI and machine learning, how does it affect me and my community, what benefits and drawbacks does it have, and how can I affect AI? And we have approximately 100 hours of curriculum, but all of those answer these questions, and you keep building on your understanding of those questions. There are 6 building blocks that all AI for all curricula follow. I've just been talking at you all this time. We don't actually believe in that. We believe in active learning, universal design for learning, seeing things lots of different ways, showing the impact of AI, also data literacy. A lot of understanding AI is about understanding where data comes from, what predictions you can make from it. Diverse job descriptions and applications. So there's a lot of different things you can do with AI, and a lot of different kinds of people go into AI with different backgrounds of different races and genders. So we want students to be able to see both windows and mirrors, people like them program, people not like them program. And more importantly, it's important that people like them program, because we need bicyclists to help us understand AI systems that can find optimal bicycle routes. We need musicians to help us find new things AI can do with music. So things like that. Like I said, discussions, Google Slides, worksheets, check for understanding Google Forms if you're teaching online. If you're teaching in person, you can wander around and hear what people are saying to each other in conversations. If you're teaching online, that's harder. So a friend of mine used Google Forms and recommended we did that as a way to ask questions. There's many videos and checks for understanding. Next, questions on the side, so students always know why they're watching the video. They should only be about a 2-minute clip. Making sure that there's closed captions and text overviews of everything, so that students who are visually understanding it and students who would better read it all have their options. Lots of research projects and presentations. You can explore online resources. Sometimes there's group embodied learning and interviews, and some programming, and in AI and dance, there's choreography. People often ask about the assessments. At the end of each lesson, there are essential questions that we're very interested in students developing understanding of. So like there's these questions for every single lesson, basically all the time, but we also have more specific ones. And there's also just quick for checks for understanding and final projects that we provide rubrics for that talk about explaining how AI works. And you can also just, as your class is having discussion, figure out what students are saying, what they are and are not understanding. So I wanted to make this more interactive. Like I said earlier, we're all about interaction. So starting with active learning and diverse applications, just understanding what machine learning can do. Both of these were taken from the How Neural Networks Work curriculum. Actually, I think the WOMBO art is new, and WOMBO art was made, was for the GANs. But here are some links. You can play with these things. And both of these things require AI. Nope, hang on. It thinks I want Giphy. There you are. Both of these things require AI. So in this case, you can go to any random place. So this is the New York Botanic Garden, and it will guess what it sounds like in that place. I don't actually want to give you all my home address, but I've put my home address in there, and it did sound like what my home address sounds like. I live in New York City, so you could hear all the like car sounds and all of that. This actually will take a little bit of time, but let's say I wanted, well, here, they give me an example, sunset cliffs, and I want it done in a watercolor manner. It'll take a little bit, but we can come back to it in a minute. Oh, no, it's creating, you can see it as it's creating. So you can play with these things and then get a better understanding of what AI is. Starting by, you know, what did your activity do? How is it connected to the other activities? If you want to answer that question in the chat, it would be helpful so that I know what people are seeing, but I'm going to keep moving. Another example of active learning is just when we find the definition of what AI is, which is in our Explore AI curriculum. For the next minute, this says 2, but for the next minute, while you're playing with these WOMBO art things, here's sunset cliffs in watercolor, for instance, while you're playing with these WOMBO art and other things, come up with everything that you can think of that might be AI, that might not be AI. Just start typing them in the chat. So there's some examples on the slide itself. You can see like sci-fi examples are fine, real world examples, just any examples you can come up with. Or whatever. How about like, so there's some examples in the chat there. Self-driving cars, Terminator, the robot in After Yang. Yep. Princess Leia in Rogue One was made with AI, smart speakers. Cool. So let's take some of these examples and then put them on a spectrum. So what we are going to do is we are going to go to this Jamboard. And actually I can so on this Jamboard, I don't really want to switch the tab it's looking at. You can click on the left where it says sticky note. And then you can put your name. So I'm going to put Sarah on a sticky note. And I can move this sticky note around. I can move it to the AI section or the not AI section. So everybody make a sticky note so that we can do this. I'm going to probably keep my sticky right here in the center so that I don't. Cool. That's enough people with stickies. You can please keep making stickies, but I'll start. Let's start with a checkout counter. So we're saying like those things that when I scan a barcode, tell me how much the price of something is. Is this AI or is this not AI? You see Storm's moved over to AI. There's a couple of people moving over to not AI. We've changed our mind. That's okay. You can totally change your mind during this. All right. So what I would then do, if this were my classroom, is have built up a culture where it is, you know, cool to cold call on people and ask them their opinions. But I haven't in this classroom yet. You guys don't know me. I do like that there's people sort of inching over towards maybe AI. So if somebody who says not AI could put in chat why you definitely think that these scanning barcodes is not AI. If someone who thinks it might be AI might like to say why it might be in chat. I'm not sure what the noise is. Yeah. So in chat, it says, well, all the information is already programmed into the system. There's no question. When I scan this barcode, it definitely is a barcode on crackers. It's not a barcode on anything else. The computer doesn't have to guess, maybe this is crackers, but maybe it's cheese, right? So that would imply that it's not AI. Still a program. Still some computer is connecting this barcode to this answer. But it's not necessarily AI. However, I love Storm's answers here as well, that it is probably able to collect that data. It knows what now it knows what sorts of things you put in your cart. And now that it knows what sorts of things you put in your cart, it might guess, well, what might you like to put in your cart in the future? What should we advertise to you? Right? So see how I said the word guess there. I might, if I bought crackers, also want to buy cheese because lots of people buy crackers and cheese together, but I might be lactose intolerant or just not like cheese and be just buying crackers. There is a guess involved. So we would do this a couple times in the classroom, but for AI for All, our definition is a discipline concerned with the designing of computers that make predictions and decisions. An important thing to note here, our discussions at AI for All don't usually have right or wrong answers. Our checks for understanding usually have right or wrong answers, but discussions, what makes sense, what doesn't, are very much built to be things for students to interact with, and they should have different opinions. So like, we wouldn't necessarily expect you to come up with exactly our definition of AI. This activity is to get you to start thinking about what you do and do not count. So then you can compare and contrast the definition. And this is the sort of thing it even makes sense to do in a language arts class, as you're talking about definitions and examples and how people build definitions. However, I also wanted to clarify, most AI we talk about nowadays is using machine learning. In machine learning, the computer learns from data it is fed rather than being told by a programmer what to do. If all machine learning is AI, but not all AI is machine learning. So what do I mean by that? So I graduated college 10 years ago, which isn't all that long ago. But when I graduated college, my AI class was going through a tree of possible moves that you could make in chess. The programmers told the computer any given move and would suggest these moves are particularly good moves, we think. These moves are particularly bad moves. And then the computer would look at this tree and it would assume that the human player would play the move that was best for them. And it would have had that programmed into it. This was probably the best move for the player given this situation. And given the player's likely to do that, me, the computer, I should do this. There's a specific algorithm that it's called min-max that does this. That was all, it didn't learn those moves. Some programmers put into it, we think these moves are good. But it was still guessing. It still had to guess that I would make the better move for me. So that's AI, but it's not machine learning. AlphaGo, which was a couple of years ago, beat the best Go players at Go. That had never been told how to play Go. It hadn't been told these are good moves, these are bad moves. We tried that. Go has way too many moves to do that with. It was just given millions upon millions of Go boards to look at and figure out for itself what moves were good and what moves were not. So that is machine learning in addition to being AI. So let's talk a little bit about machine learning, again, in a vaguely active manner. Here are words I made up. Kalas and batas. Here is a bunch of kalas and here are a bunch of batas. And here is a shape. I promise you the shape is either a kala or a bata. Which shape is it? You can put in chat what you think. Got a bunch of kalas. So far, no batas. Someone tell me why. Why do we think that this is probably a kala? It's got lines and points. Yeah, the batas were kind of smoothy things, and the kalas had lines and points, and this had lines and points. So you, a human being, were able to tell that this is probably a kala based on the information that you received before. A computer would not have been able to do that in quite as few examples as you guys just did. You've only had 3 examples of each. But basically the same idea. The computer gets millions upon millions of examples and draws patterns based on that. So that's how a little bit about machine learning. I also mentioned AI for All talks a lot about data literacy. What does it mean to make predictions? So here we have Facebook peak breakup times according to Facebook. And this is peak breakup times according to Facebook based on in like, I forget, 2006 or so. So it was basically just college students on Facebook at the time. You can look at this chart, see what it tells you. Now let's pretend an AI for All student 100 miles away who you've never met before says, I'm wondering if my significant other is going to break up with me. And the day is December 25th. Do you think, based on this chart is the only information you've got, really, that this person is going to be broken up with on December 25th, which is Christmas? You can say yes or no. Unfortunately, I can't do anything about the fact that, as I mentioned, I live in New York City, and so the outside of my apartment sounds like a lot. Yeah, so a lot of people are saying too cruel, right? Because that's what the chart says. On December 25th, very few people got broken up with. But can you say you definitely won't get broken up with? Nobody ever gets broken up with on Christmas. Can't really say that either, right? Like there are some people on this chart who did get broken up with on December 25th. So it's a prediction. It doesn't know. It only has the information that's fed it. Probably most AI systems have more information than exactly, one chart. But it can only do things based on what it knows and make predictions based on what it knows, which is exactly how machine learning works. They only have the data they're given. Can't be 100% sure. They build models based on what they've seen before. And like I said, this graph might actually look very different now. So then once you understand this, you can talk about, okay, how do, can other people not see the screen? I'll stop referring to it if you can't see it. How do past data, might that bias the outcomes? So you can have that conversation now that they understand, what data it's learning from. I am going to come back to that question after I let you guys play with Quick Draw. So this is Quick Draw. Quick Draw, you click this Let's Draw button. It tells you to draw something.
I see wishbone, or garden hose, or balloon. Oh, I know, it's light bulb.
You don't have to draw very well to get to Quick Draw to draw well for you to guess.
Cloud,
In fact,
I see tree, or rain, or brain. Oh, I know, it's sheep.
One of the things I like to say about this game is my sister is actually an artist. And my sister is way too good at drawing for this game. It's very much not testing how good you are at drawing. My sister, in 20 seconds, has a super detailed thing. But since most people can't, so you just play with Quick Draw for the next close to a minute or so. All right. I'm going to keep going. You can type in the chat how many Quick Draw guessed. Also, it's a lot of fun to see whether Quick Draw or humans do better at this game. And then it's sometimes very fun to see if you can get a human to guess before Quick Draw. There are some things that humans go, oh yeah, that's very obvious, but Quick Draw doesn't have enough data that looks like that. So the reason why I bring this up, one of the things that a human might have guessed that for a while Quick Draw wouldn't, is a high-heeled shoe. So if you close your eyes and picture a shoe, there's a video in the curriculum that says this. Close your eyes and picture a shoe. Some people will picture tennis shoes. Some people will picture, high-heeled shoes. What doesn't, it depends on sort of what your cultural context might be. But enough people drew Converse-style, tennis shoe-style shoes that Quick Draw didn't recognize that high heels could be shoes. So if you go back to the question I asked about bias earlier, how might making predictions based on past data bias the outcomes? If you have human data, even though it is not a human system, it's an AI system, It's learning from the human data. Hello. That's part of this, like learning about bias and how bias can happen based on past data. But also worth noting, every time you put something into QuickDraw, Google is building a model that can tell what people are drawing based on pen strokes. Each time someone plays the game, they give the model more data to learn from. It's learned from lots and lots of people playing the game, just like you did. A computer figuring out how to do that based on data is machine learning. Alexa, Siri, self-driving cars, the YouTube recommendations are all also machine learning. This is the data it's collecting. Key ID, a unique identifier for each drawing, the word you were told to draw, whether or not the game recognized it, when it was drawn, which country it was drawn in, and also the pen stroke order. So a lot of people, when they play quick draws, start to like scribble out something that they don't like. Google doesn't recognize that that's a scribble. Google still thinks you're drawing. This is the information it takes. You can, in fact, see the whole data set at that GitHub link. So after you've played this game with students and they see what data QuickDraw is collecting, you can ask them, is it okay for Google to use your drawings as data? Why or why not? What do people think about the data for QuickDraw? I also give you a couple of, like, does it help that you know it's all anonymized? It knows what country you're in, but it doesn't know like which computer drew it. Does it help, like, could you have known that they were collecting the data? So if you go back to the homepage, it says help teach it by adding your drawings to the world's largest doodling data set. So if you read that, you maybe knew that you were adding data to your data set. Many students I've run this with have said, well, yes, of course, we know that everything we do is online all the time and being saved by people, which is actually kind of neat to know that our kids are that aware. Other kids have said, well, I really wish before we press the button, it said, we're collecting your data. Are you okay with that? Yes, no. It could have been clearer, they think. And other students are, in fact, okay. Well, because it's very anonymized, because it's just drawing, it's nothing important, right? So you can start this conversation about privacy. Some other examples we have of things we do talk about in impact, bias, and what the impact is in varying areas of bias, environmental impact. It takes a lot of computing power to run these machine learning systems, but also you can use these machine learning systems to help find where animals are that need more help, or to better optimize your energy. You can talk about surveillance, you can talk about misinformation, and I put next to each of these places which lessons discuss those things. You can also talk about fairness. And in all of these cases, basically anywhere that there is a ethical impact of some variety or another, there's thoughts on policy. There's often not policy, because many of our policymakers don't actually know that much about AI, and voters don't necessarily require them to. And so, but there are some places that do have policies around these things, and you can talk about, well, are these policies you want? Do you want there to be more policies? So I think of these very much as social studies lessons. They're lessons in helping you understand the world and what policies you might want. For instance, facial recognition was banned. The first two cities to ban it are San Francisco and a city near Boston. And in both cases, there's a ton of tech workers there. And I hope that doing these lessons through open learning will help your students bring that thoughts to places where there are possibly less tech workers that are very involved with policymaking in those areas. I also promised diverse role models. At the end of each bite, there are some role models, and also the how stuff works. And in our longer 30-hour curriculum, we have just scattered throughout people who work in AI. And we want to make sure that we get a broad base of lots of different people who work in AI. So this person works as a policy advisor for Congress people, and also to help them learn about AI and make those kinds of policies. She also has been a broadcast journalist, also trying to make sure the people know more about AI. This person is an artist, and she uses AI to make her artwork. But I also, I started with, I am a teacher of this variety. I majored in computer science, but also I'm a human who loves theater and cello. So I try to give you what information I can find on other things these people do. So she is an artist who uses AI. She also uses art to teach Mandarin, and has worked as a machine learning engineer at Facebook. I also usually try to give education so that students who are high school students, right, and are thinking about what they want to do with their lives in college can think about what different kinds of paths lead you to these sorts of jobs. And this person is a healthcare researcher. She uses AI to develop personalized mental health plans. She's also used AI to track the progression of diseases. And again, like as a human, she was born in Trinidad, and has worked as a research fellow in biomedical modeling at Imperial College London. So you can see like policy, art, medicine, AI is used everywhere. Their backgrounds are from everywhere. Here are some cool people. Cool. Usually when I introduce these people with my students, I will give them their names. I will give them the links on the slide, and I will have them tell me what are some cool things you notice about this person, so that they can connect to the things that connect to them, and see things for themselves. So that's often how I start classes, actually, is I'll put one of these people up, even though it's at the end of each slide deck. When I'm teaching it, I tend to start with it, but curriculum resources. These are all the curricula available. I highlighted here the ones that I think are particularly good places to start. Bites are short 1 to 10 hour lessons that deep dive into one specific topic. AI in drawing doesn't so much deep dive into the subject of drawing. It's actually just a very quick overview of AI, but it's using Quick Draw. So that's why it is AI in drawing. But yeah, it covers like what AI is and bias and privacy, as you guys saw a little bit earlier. AI in the environment talks about how AI gets used to identify animals and endangered species and build policy around where those endangered species are. Deepfakes are like anytime you see a video of someone doing something that someone didn't do, or like a fake someone doing something, that's deepfake. AI and deepfakes talks a little bit about that, and also just how to critically think about the information that you're seeing and presenting. AI in dance has a choreography project using an AI system. So you get to watch programmers work with dancers to make this system. And then you work with the system yourself and sort of go through an iterative process. Facial recognition is about facial recognition. Ethics covers fairness and privacy, fairness, and explainability. And it takes the lens of you're a CEO of a company. Come up with the ethics for your company and how you would make something based on these ethics. So AI and ethics, the criminal legal system talks about how AI sometimes gets used to pick bail and parole, and like some issues with that. AI and COVID-19 talks about how towards the very beginning of the COVID-19 pandemic, things that we were doing to like track where the disease was going, to get people care, things like that. So those are the bites, they're deep dives. Explore AI is a wide overview. None of it involves programming in Explore AI. Sentiment analysis in NLP talks about using sentiment analysis. So deciding like, is this article positive or negative? What that is, how it gets used. NLP is natural language processing. So like anything involving words that are normal human words. And then the students actually, this one has some programming. The students build a sentiment analyzer. First, without using the machine learning, they're just looking for positive words, and then using a library that had already learned what words it considered positive and negative and why, and discuss the accuracy of that. The how it works lessons are short lessons that describe how specific technologies work, how neural networks work, RNNs and transformers, which work with text, CNNs, which are object recognizers, GANs, which like the WOMBO art that we did earlier describes that. We also have a corporate partner lesson. Nielsen collects TV data, and they created a lesson about using that TV data. So it's under corporate partner lessons for us. And you can see we have like a doc that if you want to do, there's approximately 100 hours of curriculum. If you want to do all 100 hours, it's in that scope and sequence doc, what order I would do them in. Very few people want to do all 100 hours. If you have more like 3 to 5 hours, there is a course pairings document. You can click on the link and see the course pairings document, or you can like all of the things that are highlighted in the same color go well together as a lesson. Learning what NLP is and then how NLP works. Facial recognition and the criminal legal system work well together because they're both criminal legal system things. AI in the environment, AI and dance, AI and facial recognition are all CNNs. So you can do any one of them and then how CNNs work. So if you have more time than a bite for deep dive and then you want to like dive a little further into exactly how it works, you might want to check out the course pairings. We have a million lessons that are about policy and, understanding how people interact with these things that work well and ethics and such that work well if you are teaching humanities. And then we have a couple of lessons that involve programming. If it's highlighted in yellow, it contains programming. If it's highlighted in green, it doesn't necessarily contain programming, but it has the students design something, and it's possible that if they are programming students, they can program the thing they've designed. And then these purple lessons don't actually involve programming. They also don't even actually involve very much math. For instance, CNNs work with matrices, and matrices are columns and rows of numbers. And that's what I tell the students. Matrices are columns and rows of numbers. And then you can do math to those columns and rows and numbers, and it will result in finding lines or circles on images. But you don't need to understand the math that the matrices are doing to understand that that's what a matrix is, and then to possibly want to, in the future, be more excited when you learn about matrices and the math behind them. So those are the lessons. We also offer... when we create new lessons, we usually teach them to teachers, and we have recordings of all of those lessons on our YouTube channel. So you can relook at them later. We also sometimes host meetups for teachers who are teaching the curriculum to talk to each other and see what's working and what's not working and such. So if you're interested in more, we have bit.ly/open-learning-teachers, which is where you can see examples of the curriculum as well as sign up to see the rest of the curriculum. It's all free. We just need you to sign up so that we know people are using it and can keep track of like, we have, several hundred teachers in these places. So you do need to sign up to see some of the curriculum, but it's all free. And if you have any questions, you can email me at sarah@aiforall.org. That is everything.
Wonderful. Thank you, Sarah. We appreciate you taking out time today to talk to us a little bit about AI, as well as providing some amazing resources.
Do we have time? Yeah, maybe. We have a little bit of time if people have questions.
Yes, absolutely.
Let me see if... We're running with Maryland, for instance, a lesson with a bunch of social studies teachers and just talking about, like I mentioned, all the policy and such implications. I am looking for our YouTube channel so you can see that. But I don't have it memorized where it is, so. Yeah, that's our YouTube channel. So there's a question in the chat. What do you recommend to start for pre-K through 8th grade? Any lessons that focus on reading and literacy? We focus mostly on high school. I have taught this with middle schoolers. So I generally think at least as low as 6th grade, the lessons work. But I do know if you go to AI for K-12, there are a lot of teachers who are doing a lot of super cool things with younger students. And a lot of the activities that we offer, you can run with younger students, like using Teachable Machine to build your own AI system, things like that can be done in the younger grades. And that thing I did with the kalas and the badas, right? You can do that with little kids and help them sort of see how they learn new words. I also have one with positive and negative reviews where I make up a word in the middle of a sentence, and I have the students say what do you think this sentence means with this word that has never existed before? So that they can understand how to make sense from words. That's in the sentiment analysis and NLP curriculum. But yeah, if you're actually mostly looking for younger students, there's other places with more resources than me. Cool. I would probably love to be back for the summer PD workshop. I am not currently intending to be, but I would like to be. So I'll look at it when it is and such. I'll also be at CSTA and ISTE, and so if you're at either of those conferences, you'll see me there. Thank you very much. Quick Draw is extremely addictive. I agree. I had so much fun building that lesson. You can see at the end of the lesson, there's a slide of other cool stuff. Different countries draw circles differently, for instance. And that actually says a lot about how that country writes. And that was super cool. You can see that they use Quick Draw for silly fun things like taking a real world picture and turning it into a doodle, or taking something that you're starting to draw and turning it into pixel perfect art, because they have a tendency to know what you're drawing and what that means, or finishing something you start with. So there's a question, am I familiar with computational sustainability? I am familiar with some of the concepts around it, but if you are referring to a very specific thing, I am not. Like, I don't know if there's a computational sustainability curriculum or something. Mostly I'm familiar with things that different people are doing to try to decrease the amount of energy it takes to run these AI systems. So everyone should remember, well, I have your ears. Everyone should remember to fill out the form that is in the chat. And you can, I mean, it's staring right there at you, but bat.ly/open learning resources, open learning features, takes you to this site, so you can always go there. Yeah. So computational sustainability is about how computer scientists, in the chat, how computer scientists are using algorithms that work to solve real world problems based on the UN sustainability goals, focused on human-centered design. Yeah, I'm aware of that. And we're aware of that general movement, which I think is pretty cool. I think most things are pretty cool. But now I think it is about time to return to the stage for wrap up. Thank you all very much for showing up. I'll hang around for a little bit because I'm here to answer questions and such. Okay, I'm gonna pop off.